Okay, hi. This is a screencast showing constant velocity, um, or zero acceleration. The data points that I'm showing right now is a position time graph for the BPV lab that we did the beginning of this year. That was like the first lab that we did. And so I got these data points, from Tracker. And you can see here that there's constant upward relationship between our position and time. And as we already know, our velocity is uh, pretty much the relationship between position and time. So our velocity is the slope of our position time graph. So as we can see, go page two. So this is a graph of the our velocity. So like the different points of our velocity, and I inserted a linear fit line, and then we can see that the slope is 0.5687 centimeters. Oh wait, yeah, centimeters per second over second, centimeters per second over second. So actually that unit and our slope is our acceleration. So yeah, our slope is actually our acceleration, and we can find that our slope is very close to zero right there. And so I'm gonna okay. So I tried drawing an acceleration time graph, and like our velocity time graph, it's just all over the place at different points in time. But it's not as close to zero as I would as like this should be. But then again, this is a real life model. Um, there's a greater slope of negative 24.68, where in like theory it should have been like right by zero. But that's okay again because it's a real life model. But then if we go to our velocity time graph again, we can see that it is pretty darn close because our slope or our acceleration is our slope, right? So if we just look at this, we can see that our acceleration is about 0 centimeters per second over second. And so that's actually closer, that's really close to zero. So I would have just based it off that rather than our acceleration time graph. Um, so yeah, so you can see that when there is like sort of a constant upward relationship between our position and time, we could see that there's sort of like a very constant relationship in our velocity where it's almost a line and pretty much almost doesn't change at all. And then whoops. And then we can see through that to the lack of change in our velocity that our acceleration um barely like differs or barely changes because the less the velocity is like the less the relationship between velocity and time, the smaller acceleration. If that makes sense. So yeah.